On the range.
Alright, today we're going to talk about domain and range. So first, you should always know that the domain talks about the, how'd you say it again?
The x values that are defined.
The x values that are defined, and the range are the y values that are defined. Alright, so let's start with this equation, and we're going to find the domain and range for it. We have f of x equals 1 over x squared minus 4. Now the best way to find the domain and the range is to think about not what x and y can be, but what x and y can't be. So let's start with the domain. Alright, so let's find out what x can't be. To find this, we set x squared minus 4, the denominator, equal to 0, because we don't want our function to be undefined. So x squared minus 4 equals 0. Isolate the x, and we get x equals plus or minus 2. Alright, so this is what x cannot be. So if we want to express these limitations in our domain, we would note that for all real numbers of x, x cannot equal -2 or 2. Now I put this into interval notation, but if you want you can just write it out like all real numbers where x does not equal plus or minus 2. Interval notation, you always want to put parentheses on the side of the infinity symbols, and this is just saying like for all like the numbers going this way, it can be all numbers from negative infinity to -2, but it does not include -2. If I wanted to include -2, I'd put a bracket, but since we can't include it here, we'll just put a parentheses. And if you want to connect different segments, you have to put a U in between the segments. Alright, so that's how we found the domain. To find the range, you just have to like really just look at the problem here. Since there is a 1 in the numerator, we know that y could never be 0. So if we want to write the range, we could write all real numbers where y does not equal 0. Or we could write it in interval notation and put -infinity, comma, 0, parentheses, don't include the 0, connect that to 0, positive infinity. So if I were to look at this, I'd know, oh well, I guess y can be anything, but not 0. Alright, now here's another example. Take the equation f of x equals 3 times the square root of x minus 2. Now remember that I told you that in order to find the domain and ranges of the equation, we want to find the limitations of the equation, what x and y can't be, in order to find what x and y can be. Alright, so if you took algebra, you should recall that anything less than 0 under the radical, so any negative number under a radical, is an imaginary number, and we want the values of the domains and ranges of the function to be real. So to find what x can't be, let's set this, whatever's under the radical, x minus 2, as less than 2, then we're going to have some problems. So that's your limitation right there. If I wanted to write this in interval notation, I'd write the domain as 2, and I'd write a bracket because you can include the 2 because it's okay to have a 0 under the radical. So you write a bracket, 2, positive infinity. So I know that x can be anything that's 2 or greater. Now, for the range, in this case, it can be anything greater than 0. 0 or anything greater. I know this because if I plug 2 back into the x, the equation would read 3 times 2 minus 2 equals, and that would equal 0. So I know that the range can never be anything less than 0, because this can never equal a negative number.